is. Okay. So if we know just one concept out of this, we know that throughout the projectile motion, right? Throughout the projectile motion, the x component of initial velocity remains constant. So if you assume that this is u and this is ux and uy, ux will remain constant throughout the motion. So this will be ux, and even when the object reaches the ground, the horizontal component will be excuse me, horizontal component would be ux. So there is no change in the horizontal component, that is ux. But what varies is uy. Now, the moment you say that ux remains constant, that option which has negative ux is the wrong option, right? So the only possible options are C and D. Now, if you look at C, it says the same velocity as that of A. So if that was the case, here the velocity would look like this, u, and the object should be going like this, which is not the case. So the object is actually coming down, in which case the resultant velocity should be acting downwards, which means the velocity here is actually minus 3g, and that's how we get the resultant velocity acting like this. Therefore the body will come downwards. Okay, so this is the most simplest explanation for this, the logical one. Let us now look at the numerical part of this, or let us say the analytical explanation for the same. Let us prove what all things we said now as statement. Let us prove them logically. I'm sorry, let us prove them arithmetically. So say we have the ground here, point of projection is A, it reaches C, it is projected with velocity u at an angle theta. The moment I say this, I know this component would be u cos theta, and this component would be u sin theta. The object goes through a projectile path, it lands here at C, and at C we have two different components again, which is u cos theta and u sin theta in the opposite direction, and we know that resultant velocity v acts here, right? So okay, I think if we write it like this, then we assume that all things are correct. Let us write down only the component. So this is ux, and this component here is uy. So this is the initial part of the motion. So when we arrive at the final part of the motion, what we get is this horizontal velocity would be vx, and the vertical velocity here would be vy, and the resultant velocity would be v. Now we know that the final velocity v has two components, which is vx, vy as well. Now what is vx is equal to? See, vx is equal to ux plus ax into t. Similarly, what is vy is equal to? Vy is equal to uy plus ay into t. Now we know that ax is equal to 0. Why? Because there is no horizontal acceleration, and we also know that ay is negative acceleration due to gravity. Ay is minus g, which means vx is equal to ux. So when we say vx is equal to ux, in the final position, what is the vx here? Vx here would be equal to ux. Therefore we can say that vx, that is the x component of final velocity, is equal to ux, which is x component of initial velocity, which is equal to u cos theta, right? Now let us find out the case with Vy. See, when we go for Vy, we can write that Vy is equal to Uy plus, instead of Ay, we can write it as minus G into T, right? Now, what is Uy? Uy, we know it as U sine theta. So this becomes plus minus G into instead of T. See, what we need to understand is the object was in initial position at A. When it completed the motion, it is in the final position now. So it has completed the motion, and when it has completed the motion, what does T stands for? T stands for the time of flight, because this is a projectile motion, right? So T stands for the time of flight. So instead of T, I can write here time of flight. Now, since it is time of flight, we can write that Vy is equal to U sine theta plus minus G into, what is time of flight equation? We have it as 2U sine theta upon G. Therefore, what is Vy is equal to? G by G is 1. So what we get is U sine theta minus 2U sine theta, which gives us that Vy is equal to minus U sine theta, or we can write that Vy is equal to minus U. What is U sine theta? See, U sine theta, we have written it here. What is U sine theta? It is Uy. So Vy is equal to minus Uy. What does it mean? It means that the y component of final velocity is equal to negative of y component of the initial velocity. Apply this logic here. What do we get? Y component of the final velocity is equal to negative of, right? Negative of y component of the initial velocity. What is the initial velocity in the y component? It is 3j. So what we get is 3j. So y final will be equal to minus 3j, and we know that Vx is equal to Ux. So what is Ux? According to the question is 2i. So we have that correct option where 2i and minus 3j there, which is option D again. Okay, so that would be another explanation for the same. Now, one question that may come into your mind is, how do you say that this angle is also theta? It should make sense mathematical and logical as well. So let us try to understand the mathematical part of it. So suppose this is the diagram we use for the reference, same diagram, and we know the equation that tan beta, where actually, okay, I think it's better we draw another diagram. Let us say a body is projected from A, right? From A with velocity u at an angle theta, right? Now this component is u cos theta. This component here is u sine theta, and we assume that at this point the body is coming down here with velocity, final velocity v, where this is, okay, where this angle is what we call as beta. Okay, so we know by equation that at any point in the trajectory of the projectile, we can say that tan beta is equal to, the equation is u sine theta minus gt the whole upon u cos theta. But again, for the motion from A to B, what is t is equal to? T is equal to time of time of flight. And what is the equation for time of flight? It is 2u sine theta by g. In which case we can write here that tan beta is equal to u sine theta minus g into, what is the value of t? It is 2u sine theta upon g, the whole upon u cos theta. So now g by g is 1. U sine theta minus 2u sine theta is minus u sine theta. So we have minus u sine theta by u cos theta. Therefore, tan beta is equal to minus u by u is 1 minus tan theta, which means beta is equal to minus theta. Otherwise, it explains that if an object is projected at an angle theta, it will hit the ground. It will hit the ground at an angle minus theta, which also explains our claim that if Vx is equal to Ux, then Vy should be minus Vy, because it is this component that acts downwards, right? So now if we draw the diagram here at B, this is Vx and this is Vy. Okay, so that's the explanation with this question. I think almost all of the concepts are explained. No need to go any further in this specific problem. Having said so, let's start the next question.